Hello guys, welcome back to my channel Vishwa World, and this is class 4 where we will be continuing with the leftover topics of the previous class. And in our previous class, we have started with the exercise 1.3, that is the real numbers and the decimal expansion. And there we mainly focused on the decimal expansion of the rational numbers, where we have gone through the theory as well as solved some examples. And in theory, we have learned the property of the decimal expansion of the rational number, that is a number whose decimal expansion is either terminating or non-terminating recurring is called as the rational number. And the best examples which we picked were one is 7 by 8. Okay, for this example, the quotient was 875 and the remainder was 64 and it was getting terminated with 0. Okay, this is the best example for the terminating numbers. And the second example was 10 by 3, where the quotient was 3.3333. It was continuing, and the remainder was 1. It was continuing. Okay, this is the best example for the non-terminating but recurring number. So now with this property, the property of the decimal expansion of the rational number, we can easily derive the property of the irrational number, that is, which is opposite to this property. A number whose decimal expansion is non-terminating and non-recurring is called as the irrational number. Okay, and if you go to some examples, then the best known example is number pi, whose decimal expanded form is 3.141596 sorry 592 653, and it goes on. And if you see here, there is no recurring pattern here. Okay, and if this example is a bit complicated, then we can easily build our own examples. Like for example, if you take S is some irrational number and assume that its decimal expansion is 0.101, again 2 zeros 1, 3 zeros 1, 4 zeros 1, 5 zeros 1, it goes on if you keep on adding one extra zero. So this is also a irrational number because there is no recurring part here. Every time it is a unique. So I hope you are clear with these two examples. If not, let's solve some examples where you will be even more clearer. Now let's go into the examples of the decimal expansion of irrational numbers. And here we have only one example in the textbook, that is find an irrational number between 1 by 7 and 2 by 7. Okay, this is the question now. So in order to solve this, first we have to find the decimal expansion of the 1 by 7, which is 1 by 7. 0.071 is 7, 3 0, 7 4 is 28, 2 0, 7 2 is 14, 6 0, 7 8 is 56, 4 0, 7 5 is 35, 5 0, 7 7 is 49, 1 0, 7 1 is 7, 3 0, and 4 is 28, 2 0, 7 2 is 14, and it goes on. If you see, this is the first repeating block and this block keeps on repeating. Okay, so now we have 1 by 7 decimal expanded form 142857. 1 by 7 is 142,857 bar. I hope you know what bar means, which means this is the recurring part. Okay. Now we need to find decimal expansion of 2 by 7, which is nothing but 2 into 1 by 7. Right? So we will multiply this number with 2. We will get 2 sevens are 14, 1 carry. 2 fives are 10, 1 carry 11. 2 eights are 16, 1 carry 17. 1 carry. 2 twos are 4 plus 1 5. 2 fours are 8. 2 ones are 2. So this is the decimal expansion of 2 by 7. Okay. 2 by 7 decimal expansion form. So now the question is, find an irrational number between these two numbers. Okay. Which is actually very easy. That is, think the number between these two number is some n1. Okay. And this n1 should be between these two numbers, but it should be non-recurring number. Okay. So if I take 0.142, it should be more than this. Okay. 1/4, I will take 3. 143 0 3 0 0 3 0 0 0 3 0 0 0 0 3 5 times 0 and 3, it goes on. See, this number is clearly between these two numbers and it is non-recurring numbers. Okay. Is there any part which is again recurring? Okay. You can't say like here 300 is there, here 300 is there, here 300 is there. No, you can't say that. If it is 300, here it is 3000. Then here it is 30,000. Then it is 3 lakh. Okay. There is no recurring part here. And since I have asked only one example, this is the one. And if you want many, then you can generate n number of examples. That is 0 point, I will take less than this number. 27, 277, 2777, 27777, 2. This is also continuing. Here I am repeating 2. I am multiplying by 2. Okay. For 1 time 2 and 2 times, sorry, 1 times 7, 2 times 7, 3 times 7, 4 times 7. I am just multiplying the number of 7s here. Okay. Every time. I am adding one 7 extra. So this is also a irrational number without any recurring part. So I hope you are very clear with these two examples, and also you also please comment me the other irrational numbers which you can find between these two numbers. So far we have gone into the theory as well as we have solved the example, and I hope it is clear to you. Now let's go into solving the exercise questions. And the first question is, write the following in decimal expansion form and say what kind of expansion each has. Okay. So and it has sub questions. We have 6 sub questions. So now let's solve each of the sub questions. So let's go into the first sub question. 36 by 100. Okay. (36 by 100). As 36 is less than 100, so we will take the decimal. Okay, and 103 is a 300. 60, take one decimal. 106 is a 600. Remainder 0. As the number is getting terminated with a decimal, like a remainder 0, it is called as a terminating number. Terminating expansion, which comes under rational number. Rational number. Okay. So the 36 by 100 is a terminating number which comes under the national numbers. Okay. Now second example is 1 by 11. 1 by 11. 0. One more 0. 11 nines are 99. One reminder. 2 zeros. 11 nines are 99. One reminder. 2 zeros. 11 nines are 99. So by this, you already clear what kind of expansion is this. Okay. As every time the reminder itself is repeating 1, 1, 1 and goes on, and even the quotient is repeating. Okay. This is a non-terminating number and rational number. We know rational numbers are those which are either terminating or non-terminating recurring number. Okay. Let me mention here non-terminating, recurring or repeating. You can either write recurring or repeating. Now let's go into the third example. 4 1 by 8. And we know how to convert this kind of number into a p by q form if you have watched my previous videos. Okay, it is just simple. Just cross multiply this. 8 4s are 32 plus 1 33. 33 divided by 8. 33 divided by 8. 8 4s are 32. 1 0. 8 1s are 8. 2. Again 8 2s are 16. 4 0. 8 5s are 40. Remainder 0. So this is also a terminating number. Terminating, and it is a rational number. So I hope you are clear with these three examples. Now let's go into the fourth one. It is 3 by 13. 3 by 13. 0. Okay. 13 twos are 26. We get 4 remainder 0. 13 threes are 39. We get 1 remainder 0 0. 13 sevens are 7 3s are 21 and 7 1s are 7 plus 2 9. 91. We get 9 remainder 0. 13 6 are 6 3s are 18. 6 1s are 6 plus 1 7. We'll get 12. 0. 13 9s are 9 3s are 27 and 1s are 9 10 11. 3 0. Okay. Now again we got same 30 here. Let's see now whether it is a recurring number. 13 2s are 26 4 0. 13 3s are 39 1 0. One more 0. 13 sevens are 91 90. So it is a recurring number. If you go on, you keep on repeating the same remainder and same quotient. Okay. So this is a non-terminating recurring number. Okay. And it is a rational number. Now let's go into the fifth example. The fifth one is 2 by 11. 2 by 11. 0. 11 ones are 11. We get a remainder as 9. 0. 11 eights are 88. 2 0. 11 ones are 11. Again 9 0. 11 eights are 88. So 2 remainder 0. 11 ones are 11. So if you see, it's clearly recurring number. Okay. So every time the number 1818, it keeps on recurring, means repeating. Even the remainder 9 2 9 2 9 2 9 2 9 2, it is recurring number. Okay. So this is also a non-terminating recurring number, and it is a rational number. Now let's go into the sixth one, sixth question. 329 divided by 400. Three 400. As the numerator is less than the denominator, we will take a decimal 0. So 400 into 10, 4000, but it is less than 4000. So let's go into 400 into 8. 8 4s are 32. 3200. We get 90. Take one more 0. 32. 400 into 2. 800. We get 100. Take one more 0. Now again, same thing. 2. 800. We will get 200. Take a 0. 5 is a 5 for the 20. 0 0. So this is also a terminating number. Terminating, and it is a rational number. So in the first example, all the six sub questions are rational numbers, but they differ whether it is a terminating number or non-terminating recurring numbers. So I hope you are clear with the first example. Now let's go into the second example. And the second example is, with the example what we have solved, 1 by 7 is nothing but 0.142857, which is recurring part. Okay. Can you predict what the decimal expansions of 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7 are without doing the long division method? Okay, in the previous example we did right here, the long division method, we found the decimal expansion of those. So but without doing the long division, we have to find out what can be the decimal expansion of these numbers. And it is very easy. If you have followed my example, there I have mentioned 1 by 7 is 0.142857. Okay, and this 2 by 7 can be written in the form of 2 into 1 by 7. So you just have to multiply this number with a 2. And 3 by 7 is 3 into 1 by 7. So multiply this number with 3. For example, if I do the 2 by 7 as, okay, 2 by 7 as 2 sevens are 14, 2 fives are 10 plus 1 11, 2 8 the 16 17, 2 to the 4 5, 2 4 the 8, 2 1 the 2. Okay, that is we get 0.285714. Similarly, we can do for this one as well. We just multiply with 3. 7 3 is a 21. 3 7 is 21. 3 5 is 15, 16, 17. 8 3 is 24 plus 5 plus 1 25. 3 to the 6 7 8. 3 4 is 12. 3 1 is 3 plus 1 4. Okay, and 4 by 7 can be written as 4 into 1 by 7, which is you either multiply this number with 4, or since we already have 2 by 7, we can just multiply this number with 2. Okay, but let's go with this simple approach. And this is actually very simple, multiplying this number with 2, but since we are following with 1 by, like 4 into 1 by 7, we'll go with that approach. 7 4 is 4 7 is 32. Okay, 4 5 is 20, 23. 4 8 is 32, 33, 34. 34 means here 3 carry. 4 2 is 8, 8 plus 3, 11. 1 here and 1 here. 4 4 is 16 plus 1, 17. 1 carry. 4 1 is 4 plus 1, 5. So this is the recurring part. 5 7 1 4 3 2. Okay. Now 5 by 7. 5 into 1 by 7. Again same. 7 5 is 35. 3. 5 5 is 25. 25 plus 3, 28. 28. 5 8 is 40. 40 plus 2, 42. Okay. 5 2 is 10 plus 4, 14. 5 4 is 20, 20, 21. 5 1 is 5, 6, 7. 0. So this is the expanded form. Similarly, for 6 by 7, you do 6 into 1 by 7. Okay, and I will leave this one, last one to you. Please do, or else if you want me to solve it, and do comment in the below section so that I will solve this for you. Now let's solve the third question in the exercise. And the question is, express the following in the form of P by Q, where P and Q are integers and Q is not equal to 0. And this has 3 sub questions, that is 0.6 bar, 0.047 bar and 0.001 bar. And we have already solved similar kind of questions in our previous class examples. And in case if you haven't gone through those videos, please do go through them so that it will help you in solving these kind of questions. So now let us solve each and every sub question. So the first sub question is 0.6 bar. Okay, and here let x be 0.6 bar. What do you have to do? The next step, multiply, and since we have only one bar on the single digit, so we have to multiply by 10. Okay, multiply 10 on both sides. That means LHS as well as RHS. 10 into x is equal to 10 into 0.6 bar. This will become 10x and this will become 6.6. Okay, 6.66 bar. 6.6 bar, okay? I'll tell you how this becomes 6.6 bar. See, 0.6666 we have. Okay, when you multiply by 10, this decimal will go one place here and we will get 6.666. Okay, and this 6 continuation I have written in the form of 6 bar. So now 10x is equal to, now we have to 10 plus 0.6 bar. We have to split this number in such a way that the second part represents the value of x. Okay, and now we have 10x is equal to 6 plus, this is x. I will replace with x. Now if I take x on this side, then I'll get 10x minus x is equal to 6. I'll get 9x is equal to 6. X is equal to 6 by 9 and x is equal to 3 2s are 6, 3 3s are 9. 3 2s are 3 3s are, okay. So we have converted the first number into the form of p by q. Now let's solve the second question. So this is of the form 2 by 3. And the second one, 0.47 bar. 0.47. I think it's just a bar on this number 7. Okay. So now let us solve. Let x be 0.47 bar. Again, since we have bar on single digit, we will multiply by 10. Multiply 10 on both sides. 10x is equal to 10 into 0.47 bar. 10x is equal to 4.7 bar. Okay. Now we have to split this number so that we will get 0.47 bar. That is 4.7777 I'm having. Okay. And what I have to do here, I have to take 4.3 plus 0.777. No, this will become 4. Okay. So 0.3 plus 0.4, I get back 0.7. Okay. So I'm splitting this in a form like 4.3 plus 0.477. Okay. This can be written as 4.3 plus 0.47 bar. This is a rough work I'm doing. Okay. So this I can split as 4.3 plus 0.47 bar. Now 10x. 10x is equal to 4.3 plus, this can be represented as x here, right? 0.47 bar is nothing but x. I will take x this side. 10x minus x is equal to 4.3. I get 9x is equal to 4.3. Okay, let me write it here. X is equal to 4.3 by 9. And since I have to remove the decimal place, and for removing I have to move this decimal place this side, okay, to the right side by 1 digit. If I have to do that, I have to multiply by 10 and divide by 10. I will get 43 by 90. 4.3 into 10, I'll get 43. 9 into 10, I'll get 90. So this is the converted form. Now let me see whether is it 0.47 bar or 447 bar. Whether the bar is applicable to 47 or only the 7. Third question, yes, the bar is applicable to only 7 because even the textbook, the answer is 43 by 90. Okay. So now let's solve the third sub question. This is 43 by 90. Now the third sub question is 0.001 whole bar. Okay. And here also let x be 0.001 whole bar. Multiply by, this time it is not 10, rather since the bar is on the 3 digit, we have to multiply by 100 on both the sides. Both sides means LHS and RHS. Okay. So 100 into x is equal to 100 into 0.001 bar. This will become 100x and this will become 1 or this will become 0.001001. This is how, if I remove the bar, when I multiply by 100, the point will come here. Okay, it will become 1.001001. Okay, this is how it will become 1.001001 and 001. Okay, it goes on. Now what I had to do again, I had to split this number in such a way that I have to get back this form. So if I have to do that, how can I split this? But is there a need to split? Yes. 1 plus, I will just take 1 plus 0.001. 0.001. Okay. And 1 plus 0.001 whole bar, because this is repeating. 100x. 100x. Now 100x is equal to 1 plus, this can be replaced with value of x. Okay, this is can be replaced with this. Now we have, if I bring the x to the other side, we will have 100x minus x is equal to 1. We will have 99x is equal to 1. X is equal to 1 by 99. So now it is converted into p by q form. It is 1 by 99. So I hope it is clear to you, this example. All these three sub questions. Now let's solve the third sub question, that is 0.001 whole bar. As usual, let x is equal to 0.001 whole bar. Since we have 3 digits, the bar is on the 3 digits, so we have to multiply by 100 on both the sides. Sorry, not 100 by 1000. Okay, because for 1 digit we have to multiply by 10, 2 digit by 100, 3 digit by 1000. Multiply 1000 on both sides. We will get 1000x is equal to 1000 into 0.001 whole bar. Now let's see what will happen. This can be represented as 0.001001001. Okay, when I multiply by 1000, the decimal will move by 3 places, 1, 2, 3. That means 1.001001001, it goes on. Okay, that means we will have 1 plus 0.001 bar when I split this number. So 1000x is equal to 1.001 bar. Okay, when I multiply with 1000. Now 1000 x is equal to 1 plus, I'll split this as 0.001 form. So 1 plus 0.001, we will get back the same number. And this part, as usual, we will replace with the value of x. Okay. So we will get 1000x is equal to 1 plus x. Now let me write here. When I bring the x this side, I will get 1000x minus x is equal to 1. So 999x is equal to 1. X is equal to 1 divided by 999. So this is the converted number of 0.001 whole bar. So this is converted as 1 by 999. Okay, in the p by q form. So I hope all these three sub questions are clear to you, and we are done with the third question. Now let's solve the problem number 4. That is express 0.999 in the form of p by q, and you will be surprised by the answer. Fourth one, express 0.999 in the form of p by q. Okay. So as usual, let x be 0.9 bar. 9 bar means repeating by itself, the 9 digit. Okay. And since we have only one digit which is repeating by itself, so we have to multiply by 10. If it was 2 digits, then we have to multiply by 100. Multiply by 10 on both sides. That is 10 into x is equal to 10 into 0.9 bar. Now it becomes 10x is equal to, and this one 0.999. When you multiply by 10, the decimal, it will move by right side by one place. Okay, then it will become 9.999, which can be written as 9.9 bar. So this will become 9.9 bar, and 10x is equal to, now we have to split this number in such a way that the second part should be 0.9 bar. That is 9 plus 0.9 bar. 10x is equal to 9 plus, this can be replaced with the x. Now if you bring the x this side, we will get 10x minus x is equal to 9. We will get 9x is equal to 9. X is equal to 9 by 9, and x is equal to 1. 9 ones are 9 ones are. So this is what you will be surprised. Okay, that is, this is also a rational number. That is 1 can be written as 1 by 1, which is nothing but 1. Now let's go into solving the question number 5. That is, what can the maximum number of digits be in the repeating blocks of digits in the decimal expansion of 1 by 17? That means when you do the decimal expansion of this, whether you will get a repeating block of 3 digits or repeating block of 4 digits or repeating block of 5 digits. Okay, but we don't know how many digits. Okay, it can be 2, 3, 4, 5 or 6, 7. That we have to find out. Okay, the maximum number of digits. So now let's go into expanding this 1 by 17. 17. Okay, 0.0. Take one more 0. Okay, 0. Now here 17, we have 180, right? What can we do? 17 8s are 17 8s are 56. So 8 ones are 8. 9 10 11 12 13. No, it can't be 8s are. Then 5 6 are. Okay, 42. 6 ones are 6. No, it cannot be this. Okay, so it can be 5s are. 17 5s are 7 5s are 35, 35, 7 5 ones are 5, 8. So we get 15 as a remainder. Okay, now add 1 0. Now let's see. 17 8s are 56. 8 ones are 8, 9, 10, 11, 12, 13. 136. 136. And the remainder is 14. Add a 0 here. Okay, sorry, 8s are 17 8s are 136. Again, 136 is less than 140, right? Again, we'll take 8. 136. We'll get again, instead of 14, we'll get 4. Add a 0 here. Now, 17 2s are 17 2s are 2 7s are 14. 2 1s are 2, 3. 34. We get remainder 6. Add a 0 here. Now, 17 3s are 7 3s are 21. 7 3 1s are 3, 4, 5. We get 9 here. 0. Okay. Now 17 6 we will see. No, 17 5 because here initially we did 17 5 85, which is less than, like, near to the 90. If we do 17 6 it will be more than 90. Okay, 17 5 85. We get 5 0. Okay, and we need less than 50. 17 3s are 51, which is more. 17 2s are 34, so we can go with this. Okay, 17 2s are 34. Okay, we get remainder out of 50. If we remove 34, we will get 16. 0. Okay, now let's see. 17 8s we got 136. That means 17 9s we will try. 17 into 9, 63. 6 on 153. Okay, which is less than 160. We can go with 17 9s 153. We will get here 70. Now 17 4s 7 4s 28. 7 4s 28. Okay, 2 4 1s 4, 5 6, 68. We get 2. Okay, 20. Again, 17 1s 17. We get 3, 30. 17 2s is 34. We can't go with 2. Let's go 17 1s again. 17 1s 17. And we will get 13. 0. Okay. Now we have 130. If we need less than 130, 17 8s is 136. That means 17 7s we have to take. 77 7 7s are 49. 7 1s are 7. 7 plus 4, 11. Okay. 17 7s are 49. We have 4 carry. 7 1s are 7. 7 plus 4, it's 11. 119. And we'll get remainder 11. Okay. We'll add 1 0. Now we need less than 110. Okay. Less than 110 means 17 17 7s are 119. 17 6 do we have anywhere here? No. So let's go with 17 6 because it will be obviously less than that. 17 6 42. 6 7s are 42. Okay, 4 carry. 6 1s are 6 plus 4 10. We get 8 remainder. Again 80. Okay, we have 80 here. And here, is there anywhere we can't go with 17 5s because 17 5s is 85. Okay, and 17 4s we have 68. If we go with the 68, it is more actually. So we had to go with again 17 4s 17 4s 68. We'll get remainder 12. Again 0. Okay, now 17 5s 85. 17 6 102, 17 7 119, 17 7 119, 17 7. Okay, we'll get remainder 1. Take a 0, not sufficient. Again, take a 0. Okay. Now, we are taking, if we are taking 2 times 0 continuously, then we have to add with 0 digit. Okay. Here also we did, right? First, for one decimal point, we can add a 0. But again, if you want to add a 0, again, you have to add that 0 here. Okay. Same thing here. Okay. First, we got the remainder 1. With this decimal, we added 0 here. But if you want, we wanted another extra 0, so we have to add 0 here. So now see, this number is similar to this, the first number. Again, what we'll do, 18, 17 5 85, we get 15. It goes on repeating now. Okay, again we got 150. Again we will do 17 8 136. So with this, we can conclude this is the longest, the maximum number of digit. Okay, that is 0.58823529144764705. So not 05 until only 7. Okay, again from here it will continue 05888 like that. So I hope you understood this question. Now let's solve the question number 8. That is, find 3 different rational numbers between 5 by 7 and 9 by 11. So in order to find the 3 different rational numbers between these two, okay, then it is very, let me see, find 3 different, it is an irrational number. Okay. First we have to expand these two numbers in the decimal form. Then we will get the limit. Based on that limit, we can generate our own 3 irrational numbers. Okay. So now first let us expand these two numbers. 5 by 7, 0, 7 sevens are 49, 1 0, 7 ones are 7, 3 0, 7 threes are 7, 7 7 twos are 47 threes are 28, 2 0, 7 twos are 14, 6 0, 7 eights are 56, 4 0, 7 fives are 35, 7 6 are 7 fives are 35, 5 0. So we got the initial number. Now if we do 7 sevens are 49, again 1 0, it will continue. Okay, so this is the repeating part. Now let us solve the 9 by 11. 9 by 11, sorry, 0 dot 11 eights are 88, 2 0, 11 ones are 11, 9 0, 11 eights are 88, 1 0, sorry, 2 0, 11 ones are 11. So this also goes on continuing. So this is the repeating part. So ultimately we have expanded these two numbers. Okay. Between we now we have to find this and 0.81. So we need to find 3 different irrational numbers between 0.713287 and 0.81. So what I can do is, first number I will go with 0.72. Okay, I have to be, it should be more than this and less than this, right? 0.725, 7255, then 72555, 72555. It's up to you. Okay, I have just taken 5, or else you can do 72, 722, 7222, 7222 like that. Okay, so you can generate any irrational number which should be non-terminating and non-recurring, non-repeating number. So this is one example. And if I go in between, I will take 79799 7999 79999. So this is one such example. And third one, I will take at the end 0.80 0.800 8000 80000 like that. I can increase the number of zeros, and this is also one such example. So we finally have three different irrational numbers between these two rational numbers. So I hope it's clear to you. The example number 8. Now let's go into the exercise problem number 9. Okay, that is classify the following numbers as rational or irrational numbers. So here we have given like there are 5 numbers here, that is root 23, root 225, 0.3796 and 7.478, 478 and fifth 1.10, Okay, now we have to classify these numbers whether they are rational numbers or irrational numbers. So I hope you would have already identified few of the numbers. Okay, now you would have been confused with these root numbers, right? And there's a one point you have to keep in mind. Okay, if the root is perfect square, okay, then it is an irrational number. If it is not a perfect square, then it is not an irrational number. So then it is an irrational number. Okay, and here in this case 23. So for example, if you take 5 5s, we get 25. 4 4s, we get 16. So 4 4s, between these two there is no number, right? So 23 comes in between these two numbers. So this is not a perfect square number. Okay, so this is a irrational number. Now the second number, we can do 15 into 15. Let's see. 5 5s, 25. 5 1s, 5 6 7. 1 5 5 1. Okay, 5 here we'll get 25 13 235 5 7 8 9 10 11 12. Sorry, this is 12. 5 7 plus 5, it is 12. 1 carry 7. Again 1 plus 1 2. Okay, so we get 225. That means this is a perfect square number. Okay, that is sorry, my duster is little wet. So the first number is irrational number. This one is irrational. The second one, as we can represent this as 15 square. Okay, and square root and square and get will cancel, it will become 15, and this can be represented 15 by 1, so which is a rational number. Okay, it is a rational. And this one 0.3796, it's very easy. See, there is no dot after this. Okay, there's no continuation of this, so this is a rational number. That is, we can convert easily into a rational number. 0.3796, you multiply and divide by 1 2 3 4, means 1 2 3 4. We have to move the decimal. 4 1 4, then this will become 3796 whole divided by 1 2 3 4. So we have converted into p by q form, which is a rational number. Now the fourth one, so this is also a rational, this is also a rational, this is a irrational. Okay, now this one, I hope you already observed the pattern. Okay, if you see 478 478, it is repeating number. Okay, it is a non-terminating and recurring number, which means it is also a rational number. And the last number 1.10110, if you see, there is no repeating block at all here. Okay, every time the zero we have 2 zeros, 3 zeros, 4 zeros, 5 zeros. It goes on continuing. This is a non-terminating and non-recurring number. So this is a irrational number. So this is the last problem of this exercise 1.3. So I hope you are clear with this exercise 1.3, and we are done with this exercise. Thank you. So guys, we are done with the class 4. That is, we have completed the exercise 1.3, the real numbers and the decimal expansions, where we have gone through the theory, the examples, as well as we have solved the exercise problems. And hope it is clear to you. And still, if you have any doubts, okay, please do comment below so that I will take my time in solving your doubts. And there is one request from my side. Please do share these videos with your friends so that even they will be clear on these topics. And if you are a first time watcher, then please do subscribe to my channel. As I get more and more subscriptions, I'll be more motivated to do the further videos. Thank you. Thank you for watching my video. Thank you.